Okay, finding zeros of polynomials. Basically, the first thing we're going to talk about is the rational zero test. Basically, all the rational zero test tells you is if you take all the number at the end, which the minus 6 will be our p, and the number in front of our largest leading coefficient, or power, which is the x to the third, but the coefficient is a 1. This is going to represent our q. So basically what we're going to do is we're going to find all the factors of 6 and divide them by all the factors of 1. So the P over Q test works like this. I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 over the factors of 1, which is just 1. So potentially, instead of pulling out an infinite number of potential zeros, I'm guaranteed that as far as rational zeros, and keep in mind this is rationals, this does not include square root of 3 or anything like that, but my potential square or zeros are plus or minus 1, so you do a fraction. We got 1 over 1, you have 2 over 1, so plus or minus 2, you have 3 over 1, so plus or minus 3, and plus or minus 6. So now I just need to be plugging in values and plug and check and see what happens. My suggestion is try to start with the middle. I'm going to try positive 2, and we'll see what that happens. I'm just going to use synthetic division on it. So when I check for 2, bring down the first number, so I get a 1. 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, negative 7 plus 4 is negative 3, 2 times negative 3 gives us negative 6. And negative 6 minus 6 is negative 12. So negative 2, or I'm sorry, positive 2 is not a 0. But I do know that if I plug 2 in for x, I will get the point 2 and negative 12, since that's remainder. So now I need to find something that works, but I know 2 won't work. If I try negative 2, I have the 1, negative 2 times 1, negative 2, 0 minus 2 is negative 2, negative 2 times negative 2 is 4, I get a negative 3, negative 2 times negative 3, positive 6. So that does work, and so notice now I know that negative 2 is a solution. Now just because it works once doesn't mean it can't happen again. The only one I can eliminate was the actual positive 2. But negative 2 is still fair game. But notice now, this is a 1x squared minus 2x minus 3. And that can be factored to give us x minus 3 and x plus 1. Now when I set those equal to 0, I get x equals 3, and notice we had that here. And we also get x equals negative 1, which we had here. So my three solutions are x equals negative 2, x equals 3, x equals negative 1. And there's my three solutions.